Hello everyone and welcome back to our channel Quaint. Today's topic of discussion is Transmon Qubits. The Transmon, short for transmission line, is shunted plasma oscillation qubit. So big. Anyway, Transmon is the short form for this. Okay. So we are talking about actually Transmon Qubits. So qubits, you know that these qubits are used in the field of quantum computing. Means quantum computers use qubits, and in case of classical computers they use actually bits. So what is the problem actually? Why Transmon Qubits are used, and not in all the quantum computers Transmon Qubits are used. Companies like IBM, Google, Rigetti, they are using these Transmon Qubits. Okay, different types of qubits are there actually, and you can use all the qubits to make your quantum computers. But there are different problems associated with the performance of the qubits. So here we are actually talking about superconducting qubits, means early superconducting qubits, which were actually extremely sensitive to noise. Okay, whenever you are making a quantum computer, so noises are there, and especially here in this video we are talking about charge noise. So if noises are there, then in that case maintaining coherence and error-free qubits becomes difficult, very difficult. That means actually creating a stable and controllable qubit is extremely difficult. And early superconducting qubits were like that. They were extremely sensitive to noise. So in case of a Transmon qubits, there is a modification. They have designed it differently to make it less sensitive to noise, less sensitive. Not actually, it is noise free. In this new design, which is being designated as a Transmon Qubits, okay, this is less sensitive to noise, and especially we are talking about charge noise. So what is done actually, this system actually consists of a Josephson Junction shunted by a capacitor, and by increasing the capacitor, we reduce the fluctuations in the energy levels to fluctuation in charge. Okay, this way this is managed, and what happens this way? This way you are actually increasing the coherence times. And since you are increasing coherence times this way, that means by using the same qubit, you can do more operations. That is the benefit. But one more thing you need to do here in this case, you have to create a ultra cold environment. The temperature is close to absolute zero. That temperature you need to maintain in case of a Transmon Qubits. Means quantum processors made by this thing. Okay, you need to maintain ultra cold temperature, and ultra cold means here it is close to, very close to absolute zero. And they normally use dilution refrigerators to achieve this ultra cold temperature. Anyway, so we were talking about this Transmon Qubits. Still there is a chance of error. Errors are introduced. This is not totally noise isolated. Not totally noise isolated. They are prone to errors. Okay, and decoherence may occur. So you need to maintain many things associated with the stability of Transmon Qubits. And normally what is done, manipulation is done. Manipulation of the qubits are required. And for that microwave plasma is used normally. Microwave pulses are used. Okay, they are used to manipulate the qubits. Means we are talking about actually Transmon Qubits only here. Okay, manipulation is required anyway. So main problem was what? Main problem was stability and how to control those things. So Transmon Qubits is nothing but a redesign of the same thing, superconducting qubits. or superconducting circuits are used to produce superconducting qubits, and this little modification is there, Josephson Junction is used. Anyway, so this was all about today's topic. So this is the end of this video. If you found this video fascinating, so please like, share and subscribe. Actually, here in this video we have talked about a new technique to produce a new type of qubits known as Transmon Qubits. Anyway, so this is the end of this video. Thanks for watching.